are going to look at an electromagnet, and this electromagnet has a self-inductance L of 56 henries. It's connected to a 440 volt power source, and so that is our battery. And the resistor that it is also attached to has a resistance of 2.8 ohms. And we are asked to calculate how much time does it take for the current to reach 75% of its maximum. All right, so what is the maximum? Well, the maximum is going to be our power supply divided by our resistance. And where that's coming from is our time equation for our current through this circuit. All right, that is our EMF divided by our resistance, 1 minus e to the minus t over our time constant, L divided by R. Right, so where is this term maximized? Well, it's maximized when this term gets small at large t. This whole thing trends to 0 as t gets really big, and makes this as large as it's going to be. All right, so 75% of the max is 0.75 or 3/4 times the max. And we are going to solve this expression now for the time t at which that occurs. And so we get some nice cancellations here. And we're going to want to get this term by itself. So let's start up over here. That means that I can bring this over to the other side. Over R is going to be 1 minus 0.75 or 0.25, 1/4. Let's take the natural log then of both sides. That's going to get me minus t over L divided by R is equal to the natural log of 0.25. And we want to find t here. And so t is going to be minus L over R times the natural log of 0.25. And we're ready to plug in. So this is minus 56 henries over 2.8 ohms, and the natural log of 0.25, which is going to be a negative number because 0.25 is less than 1. Put all that together and we get something like 28 seconds.